simply applying their algorithms and build those on top of a physical construct to make the concept not only a real possibility, but considering the fact that modern astronomy is already shifting towards the electric universe model, this flat electromagnetic model is far better explainable and provable than the current hypothesis, that being the Newtonian or Einsteinian universe. In short, the argument that there is no flat Earth model and that they can't predict is out the door. Here is how the star field would look if we removed the atmosphere. The place is Canary Island, Spain. The lens that I used here has a 122-degree field of view, and as you can see, the stars never set because they are too high for perspective to make them rise or set. Their altitude now is about 4,000 miles. This number is fairly accurate and matches the rise and set times shown in the programs such as Stellarium. Now I am going to play the same video, but with the atmosphere or atmosphere added. As you can see, the video has changed completely and the star trails look exactly like the original picture. Here is the original, taken on March 15, 2015. Now let's play the two videos side by side so you can see the effect of the atmosphere. We can do this from any location, they all work the same. And here is another test in France. Look at it carefully and compare it with the original, and let us know if we're doing anything wrong. And here is how the sun rises and sets in Salinas, California. We still need to make adjustments to the height of everything, but the atmosphere already makes them rise and set correctly. The atmosphere was the key to solving the puzzle.
This is a quick view of the stars in AutoCAD so you can understand how we draw them in Cinema 4D. All the stars you see on the model are 4,000 miles up, and the angles of the stars are accurate and they match modern science. We didn't make them up. And that Excel sheet on the left side of the screen shows all the data that we used. You can find it in the description. Here is a south view of the stars on the flat Earth with the atmosphere added. Now this should be enough for some trolls to see that wherever we are on the flat Earth, the sun and the stars will rise and set. And if they don't look like real life, then please try to understand that by adjusting the map and the height of all the objects in the sky can fix the problem. We still don't know for sure the heights of everything, and we still don't know for sure how the real map looks like. The point is that the atmosphere or atmosphere makes everything in the sky rise and set. Here is how the real sun and the apparent sun move in Cinema 4D. It's acting exactly how we expected. The apparent sun appears to move faster than the real sun. Therefore, it disappears in less than 7,000 miles away from the observer.
When the apparent sun is at 0 degrees, the real sun is at 35 degrees. And as the real sun rises at its normal speed, the apparent sun follows at a higher speed. The more they rise, the closer they get, and when they are 90 degrees, the refraction is 0.
This is a diagram I made in AutoCAD with the real elevation angles of the sun that we get from suncalc.org. This is the location and dates that I used. You can try that yourself. So when we draw the angles accurately, we notice that the sun travels faster the more it moves away from the observer. As you can see, the distance between 5 and 6 p.m. is a lot longer than the distance between 4 and 5 p.m. And the distance between 12 and 1 p.m. is very close to the speed of the sun on the Tropic of Cancer. On the globe model, you can say it's the speed of the spinning Earth in the Tropic of Cancer. But of course, the apparent sun doesn't travel in a straight line like the real sun does. So the distance between each hour should not be so exaggerated. We can draw it like this, but this is nothing but a diagram. And by the way, if perspective is the reason why the sun sets on the flat Earth, then the more the sun moves away from us, the slower it should appear to us, right? Imagine yourself in the middle of a highway. The cars that pass by you will be moving in their real speed, but as they move away from you, they look like they are slowing down. But that doesn't happen with the sun, right? In fact, the sun appears to travel faster the more it moves away from you. So perspective is definitely not the only reason why the sun goes down.
If you go on Google Earth, this is right about the area right here where I believe I was when I took that picture. Looking across, it's only about 0.6 of a mile. So I'm just a little over a half mile away, and look at the size of the tower as compared to the car that was diagonally in front of me. We were looking at the Willis Tower from this direction right here when we were on the other side of the lake. Now, okay, so let me slide the car over and shrink it down to the appropriate scale beside the boat. Do you see something rather interesting here? This building is significantly magnified. The image on the left shows the size and scale of the building next to a car at 0.6 of a mile away. The image on the right shows the same building and the same car with a boat at 46 miles away. The atmosphere really is acting like a lens. What type of lens? A convex lens or a magnifying glass. And let's just go back and hear from the experts once again what's happening with the atmosphere.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
See all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
Science is all about testable, observable, and repeatable data, right? So to alleviate the problem of distorting the edges because the magnifying glass ring is too small, I went on Amazon and I got these plastic magnifying sheets and came up with another way of doing the same thing using the sheet right here. Set the city up, a little cutout of the city, and now I've got the big magnifying glass sheet. Bring the camera right up to the lens. See, that's the normal view of the city. Now let's back up again.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
The atmosphere really is acting like a lens.
yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of the atmosphere. You're missing, a good portion of the city just by pulling my iPhone back on a 3-foot long desk. That's how much I lost of the city. We're all the way up against the glass. Now let's zoom across the lake, and wow, look at that. The lower portions start to disappear. Now let's zoom back in to get a little closer to the one that Captain Baltard was talking about here. And wow, look at this. Here's his image on the right, and here's my image on the left. Missing the lower portions of the city had nothing to do with curvature whatsoever. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface as it was moving parallel, the same height, the whole way over a flat surface. The refraction caused the sun to set. Not only that, Well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size too. Pretty close. And of course that's because as it's moving away, the magnification is still taking place, and so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set. Now, I'm just going to put forward a crazy idea for you to think about. And that is, if Rob Skiba could figure this out, I'm just going to go out on a limb here. I think it's quite possible that the creator of the cosmos could have figured out the same thing and engineered our beautiful sunsets, thanks to all that water he placed in our atmosphere. Just something to think about. Let's just say the bottom of this little stand here represents the bottom of the clouds. And so as you can see here, the light is way above, it's well above what would be the bottom of the clouds in this example. So let's see what happens. I turned off the lights and set my iPhone to record, and I'm showing myself here recording all of this with another camera, and I pulled the light back on the table, and watch what happens here. Ooh, check it out. And there's that refraction taking place again. It's got the light. It made the sun set, first of all, below the horizon in this case. And let's just show, this is just the iPhone view. I'm going to bring the cloud in here, and the platform represents the bottom of the clouds. So the sun's going down, and oop, there it is. The bottom of the clouds illuminated by a light source that's well above the clouds, moving parallel over a flat surface. So apparently it's possible for the sun to illuminate the bottom of the clouds even on the flat Earth model. I decided to repeat the test because science is all about observable, testable, repeatable observations, right? And this time, even though the previous test was done on a table with non-reflective tablecloth on it, I decided to take a piece of soundproofing that I had left over from when I was doing the audio drama for Seed the Series. And I even left the end curved up like this, so it really should prohibit any possibility of reflection bouncing off the table. But here we go again. Here's the same test, this time with soundproofing, lumpy soundproofing that would prevent any kind of reflection. And here we go. Oh, looky here. I got the exact same results. Huh.
And that's the brand name and make of the solar telescope. Now it doesn't have any zoom on it either. It's locked in at 500 millimeters. And we have shrinkage over here from the noon picture, and a little shrinkage over here. And as you can see, it's bigger. So as you can see on this day, the sun did actually change sizes throughout the day. And as you can see, it's starting to shrink back down again. And it isn't quite as big as the November picture, but bigger than the 4th of July. Does the sun change sizes throughout the season? Yes. Does it change sizes throughout the day? Yes, it does.
This is flat Earth sunset. As you can see, the sun is pretty much out of our line of sight right now due to perspective. As you can see, it's getting smaller and smaller as it goes further and further away, not down. And we're pretty much down to the last minute here of the sunset. And as you can see, it's just a tiny little speck, and it's gone. It's gone.
Of course, that's because as it's moving away, the magnification is still taking place. And so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made its set.
The sun is a personal or local objective projection. This can be verified by anyone by doing the opposite side crepuscular rays experiment, like in this animation, and see that someone looking back at someone seeing those rays cannot and will not see the same thing. A rainbow acts the same way as the sun, being that you can only see it at a specific angle, and you cannot walk around a rainbow as it will always move away from you. And you cannot see the opposite side of a rainbow. A rainbow is a source projection, and its source is the sun. Therefore, if the sun is also a source projection of an unknown source, we can start modeling the path of the sun for each observer on Earth. We did this by taking just one longitude, that being the 0 UTC meridian on Earth. And inputted the data from observations for azimuth and declination of the sun and traced the sun object for that location for a year for each 10th latitude north and south of the equator, and just let the data run its course for a year. But the model became so heavy with data and tiny hair-thin tracer lines that even with a super machine, we couldn't render the result. After some trial and error, we finally managed to get a clear view on the end result. And even with our sun being an equal distance to the observer, the shape and layout ended up in a torus field around the Earth. But it became very clear to us that based on Ken Wheeler's research into magnetic holography, that the sun we see is projected into the electromagnetic field in the sky. The objective sun follows the magnetic field lines that are unique for each location on Earth. So the real sun is a source coming from outside of the so-called firmament, which probably uses light polarization that is projected into the magnetic field and rendered through the atmosphere. It is no coincidence that all sun arcs combined create this torus-like field, and this is version 1.0. As soon as we find out how to use equal distance 3D vectoring and a formula on the angles in the data sheets from observations, we can then get a true shape in second-by-second motion in the field lines. This torus field is by no means a stationary field, as the sun moves north and south during the year. We animated this in what we call the cosmic breath of flat Earth, and this shows that by simply increasing the current in the field from the North Pole, you then push the field south, and by lowering the current, it flows back north again. It can also be pushed back and forth by an outside magnetic field from beyond the Antarctic, 90 degrees south latitude. The southern magnetic anomaly is also a moving anomaly, and who knows what more lies beyond the southern latitudes, all of which have influence on the field. From a creation standpoint, it must have a function as well. If we animate all sun positions over a year, the animation gives the impression of a wave going around the field like an outside source pushing and pulling on the field and projecting its image, that being the sun or moon, in it. We do not know yet what, where, and how this outside source is mechanically working, so to speak, but from an engineer's perspective, everything that works like a machine or clock must have a basic principle and laws of physics to discover its nature. We just have to figure out where to go from here and what experiments can be derived to either build on this or modify the basic concept. With this concept, we can boldly say we have created a working flat Earth model that can be held up to scrutiny, evaluation, testing, and experimenting to either verify or debunk certain aspects of this model. It is therefore with great honor and humility that we present this first and only working flat Earth model with an actual base in geometry, science, and observations. In the coming weeks, we will be releasing ground views of this model to show that current sun angles are dead on correct.
And in fact, because 2100 years ago, regardless of what you may think about Eratosthenes and the confusion that surrounds that, this is something that is absolutely, physical proof that we do have this piece of science from over 2 millennia ago that is based on a flat Earth cosmology and absolutely does predict the eclipses. But guys, don't ever let these ballers tell you that the eclipses cannot be predicted from a flat Earth model, because in fact that is exactly how it always has been done.
They have in their hands this device. They start to create, for example, things like the astrolabio or the sextants, which is like a tiny part of this kind of mechanism. And of course, they make the reverse engineering and they come across with the globe.
Yep. Oh, and by the way,
they have the tools. I mean that.
One thing that's interesting about the Antikythera device, and I learned this while researching it, is that guess what everything is based off of, all the rotation? 2100 plus years ago. You got it, Polaris.
Yes. Exactly.
Bada bing.
So I'm going to read this really quick. Rotation symmetry in the Michelson-Morley experiment incidentally allows many physicists to mistakenly believe that the speed of light is invariant in all inertial reference frames. Well, we just covered that. We know that's nonsense. The speed of light is absolutely variant, right? But they want you to believe that it's invariant. The speed of light is constant in every direction, but only in the rest frame of the light emitter. Upon reflection by a moving mirror, light will travel at a different speed with a different frequency. The mirror will either accelerate or slow down the light. The speed of light depends on the reference frame. The error in Michelson-Morley experiment resulted in the incorrect speculations of length contraction, yeah, boy did it, and the constant speed of light, both of which were adopted by the theory of special relativity. Well, we've already debunked that again. Well, I don't need to say it again. The source of both speculations is the Lorentz transformation, which was proposed to explain the calculation error, length contraction. Lorentz transformation claims that two simultaneous events cannot be simultaneous in another inertial reference frame because of time dilation. This is proved to be incorrect by the conservation of elapsed time. If the elapsed time is 0 in one inertial reference frame, it is also 0 in another inertial reference frame. Two simultaneous events are always simultaneous in another reference frame. Bada bing. There it is. Bada bing.
Fred Espennick, NASA's retired employee who responsible for calculating the eclipse. See the official explanation of NASA in Picture tab. And then, shamelessly, NASA wrote, he assumes full responsibility for their accuracy. From here, we can draw the conclusion. Fred Espennick is a rare human being. So rare, that even after retirement he remains the only sources of NASA in predicting the eclipse. Now, use your intellectual brain. Let's see how Fred Espennick predicts an eclipse. Please open the NASA eclipse predictions from year 1870 until 2573. Okay, it's crazy how great the man who predicts eclipse. Apparently, based on statements in the official NASA website, Fred Espennick calculated eclipses based on. Yes, Saros cycle. I am laughing again and again. No way to run, NASA. The professor also referred to a link that said, NASA software for calculating or predicting eclipses. Just try to tell him to wear glasses and read correctly, at the bottom right of this website. And what is it? Eclipse software that published by NASA as use. The Saros cycle.
In short, the argument that there is no flat Earth model and that they can't predict is out the door.
North, we know that this is north, we tested it before, that when we put it to proximity of plasma, it shows twist to the right. It means it is in accordance with the theory or the opinion. Now, when we put south side, it should twist the opposite way, as it does. Put it inside, it should spin to the left, which it does. We try to modulate it so that it will go slowly.
It's a little hard to see because of the frame rate of the camera, but yeah, I can testify that it is spinning to the left.
So it means when we turn it the opposite way, we put south pole, it should rotate to the right.
Yeah, that's very clear. Yeah, very clear rotating to the right.
So, and we have quite high spin of plasma.
Dating back decades, various experimentalists have replicated through electrical discharges different types of craters, from those indistinguishable from impact craters to anomalous craters that continue to puzzle planetary scientists. In some instances, an electrical discharge may be the only process capable of producing all of the features of certain craters. In any case, new scientific data will continue to make it more clear that cratering is not the result of periodic impacts from space over eons of time. Electrical cratering is just one of many new pathways of discovery waiting to be explored in our electric universe.
Our dome of vision, right? Can you talk about that a little bit?
Sure, yeah, I call it the personal atmospheric dome, or the PAD. And here's the thing I think people miss, is that this is not a theory, it's not an idea, it's the truth, it's a fact. And you can figure that out on your own by just simply knowing that if you look up, that's the least amount of atmosphere that there is right above you, straight above your head. So if any light is coming directly down from straight above you, that has the least amount of refraction, it has the least amount of effects. Those rays are going to come at you parallel if the sun's right above you. And then if you look to your left or right, or straight ahead of you or behind you, that is the most amount of atmosphere. So right away you can tell if the least amount of atmosphere is above you and the most is to your sides. That creates a personal atmospheric dome. We all see through it. No matter where you're at on the Earth, no matter North Pole, South Pole, wherever you might be, you exist inside of a personal atmospheric dome where everything renders to you. It is a personal atmospheric dome, and then you have to learn to understand that. So many people get caught up in the idea of here's the fooling part. You live in a personal atmospheric dome. That's what you live in. That's what you see things through. They convince the world that there is another personal atmospheric dome below you, with somebody living upside down inside it. And that's the biggest, fooling point of the entire thing. Is that no, you exist in your personal atmospheric dome. That's how you see things.
And here is another major flaw with a flat Earth model. And once again, we can use the flat earther's own tools to clearly demonstrate the problem. In this case, the Flat Earth Sun and Moon Clock app. As you can see, I have set the time to 7 p.m. on Friday, the 21st of June 2019. At that time, the sun is over the Tropic of Cancer, and you can see that Perth, Australia, on the west coast is in darkness. If we jump 6 months ahead, the sun is going to be over the Tropic of Capricorn, which on this map is further away from Perth. So logically, Perth should remain in darkness. Let's see what happens. September and December 21st. The sun is over the Tropic of Capricorn, and yet Perth, Australia is in daylight. The sun is further away, and yet we have daylight in Perth. When it jumps back to the Tropic of Cancer, it is now closer to Perth, but Perth is in darkness. The whole model is ridiculous, and this app clearly demonstrates why.
It's got to be shaped this way, I believe.
As you can see, the video has changed completely, and the star trails look exactly like the original picture. Here is the original, taken on March 15th, 2015.
Angles, and you're at different places on the earth, that light moves its angle to you. Look at how we just moved the atmosphere a little bit to the right, and now this light, which is over here, is being portrayed here. So you can say, well, it's supposed to set at 270 west. Well, now it's setting a little bit north of that, or it's setting a little bit south of that based on your location.
When the atmosphere was added, the first thing that we noticed was that spheres looked oblong when viewed through the refraction. The only way to overcome this was to make the spheres as flat as possible. For the moon, it could not be perfectly flat, or the phases would not work. So the moon is a very flat sphere, or almost flat, but not 100%.
Of course it's serious. This is capital letters B-I-G, as in Galileo. Time to rethink geocentrism.
The only way to overcome this was to make the spheres as flat as possible.
Allow me to now share the information that will close the case forever on the possibility or the falsity of the moon being a sphere. The moon is 100% absolutely not spherical, and any lunar eclipse proves it, and you can prove it too. All you need is a light source and two spheres. On the right, I'll be showing video footage of past lunar eclipses that we are all familiar with. And on the left, I will be showing what a shadow moving over a sphere actually looks like. A lunar eclipse is not, I repeat, is not a shadow of a sphere or anything else circular moving across a spherical object. How do I know? There are 4 critical points of observation everyone should be looking at, and I like to call these the conformation to surface factor, the shadow diffusion factor, the sine wave or S factor, and the reflected light factor. Firstly, I would like to point out the consistency of how a shadow naturally moves along varied surface types. This is the conformation factor. A shadow will conform to any shape that the surface takes, thus, in a way, revealing the true shape of an object. If a shadow moves along something rigid like stairs, it will take the stairs' shape, revealing the level differential from step to step. If a shadow moves along a concave object like a bowl, the shadow will stretch and skew, revealing the concavity of the bowl. If a shadow was to move over the surface of a sphere, it would stretch and skew in a spherical manner, wrapping and receding as it bevels and distorts along the sphere's surface. Note that this does not and has never happened on the surface of the moon during an eclipse. Which brings us to our next factor, the shadow diffusion factor. Note, the shadow is more crisp on the edge of the bowl than it is in the lowest portion of the bowl, and sharpens as it rises back up to the edge or the source of the shadow. Note also that on a sphere, the shadow is most diffused or scattered around the edges as the sphere's surface recedes, and it is the most sharp or defined on the closest portion of the sphere. This is because the closer the source of the shadow is to the surface, the more defined its edges. The further the source of the shadow is from the surface, the larger and more faded or diffused it becomes. Another way to say this is if you place an object on a surface with a light source above, the object's shadow will appear most sharp when the object is at rest. But lift the object closer to its light source, and you will see the shadow lose its crisp edges, and dull or fade away, sometimes to the point where little to no shadow remains. This is the shadow diffusion factor, and in conjunction with the first factor, the conformation to the surface factor, the shadow not only rises and falls, stretches and skews with the surface, but also sharpens and dulls. These 2 factors are almost all we need to find the true topography or shape of the moon. Yet one factor is missing. This is called the sine wave factor or S factor. Because the moon is said to be a sphere, the shadow that is projected onto the moon should also take on the characteristics of the sphere. This critical factor does not appear on the moon's eclipses whatsoever. The sine wave factor, or the S factor, is what happens as an object, round or straight, spherical or bent, passes over a sphere's surface. As the shadow moves onto a sphere, it is wrapping around its curve. Starting from the outer edge and moving towards the middle, the shadow takes on the spherical contour and bends upward at its height, then falls backwards in a barrel-distorted manner. The shadow will always follow the closest edge due to perspective. The shadow will continue to create the S shape until it reaches the halfway point. As the shadow moves beyond the halfway point, it begins to bevel outward again in a barrel distortion manner. When a shadow moves along a 3D sphere, the center or closest part of the sphere to the observer is the most flat, and the shadow's shape and size the most true to life. The sphere will never be flat, but the bigger the sphere is, the less acute the angle of its curvature. So, because the innermost portion of the sphere is the closest to the observer, the less curvature is observed. However, when we observe any lunar eclipse, there is no wrapping, stretching, skewing, sharpening, or dulling of the shadow. In fact, every single lunar eclipse looks as if there is one flat disk moving across another flat disk. As the circular shadow moves along the moon, it maintains its circular shape the whole way at the same pace. No stretching, no skewing, no sharpening or dulling. Hopefully you all understood that, as it was quite hard for me to put into words. Those three factors are good enough for us to see that the moon is not a sphere, but one factor is needed to realize the moon's surroundings, and that's reflected light. When another object under the same light source is in close proximity of the object in question, i.e. the moon, it should have light bouncing off of the Earth and reflecting onto the moon. When another object under the same light source is in close proximity of the object in question, it should have light bouncing off and reflecting onto it. What I mean is this. The closer another object comes to the sphere, the brighter the light it's reflecting will appear. In the made-up heliocentric lie, they tell us that the moon is reflecting the light to the Earth. But what about the bigger object, the Earth? Does it reflect and bounce light to the moon? It should, but it doesn't. Because if it did, we would then have no new moon phase, and instead more of a dull moon phase or a dim moon phase. Meaning, as the moon wanes to darkness, it should then be illuminated by the Earth. We should still be able to see the same face of the moon that we see every day, because the moon is always facing us. However, it should be dimmer and not luminous, because the Earth should reflect its massive light towards the dark moon. Especially when the moon is further and closer to the Earth on its supposed elliptical path, it should brighten and dim in its new moon phase. I repeat, speaking exclusively from new moon to new moon, the moon itself should still be visible on that new moon phase, transitioning from dim to slightly brighter, back to dim, as the moon moves in its elliptical orbit. The object also should reflect the color of its surface and the color of its light source. A gold chain will reflect gold. A green ball will bounce green light, and its reflection on the object will be green. The sun's light is yellow or warm, while the moon's light is blue and cool. Astronauts say the moon is black and white, whatever that means. But if that means it's a scale of grays running from white to black, then it is impossible for the moon to change the sun's light from a warm color and temperature to a cool color and temperature. Yes, the moon's light is colder than the moon's shade. I can understand the moon cooling down the sun's rays and making it less hot, but in no way is it possible for it to actually make the sun's rays colder than the shade at night. Meaning, if you stepped into the moonlight at night, the temperature of the sun's rays reflecting off the surface of the moon and onto your face, or thermometer, should be greatly reduced, but not colder than if there was no moon at all. When the moon comes out at night, the temperature drops because of the moon's light. This has been confirmed by many experiments using digital thermometers. But staying on course, there is no sign of a reflected light being thrown onto the moon by Earth. What does this mean? This means that the new moon has actually disappeared. While the moon is waxing and waning, we can see the rest of the moon that is not illuminated. However, when there is a new moon, or no sunlight being reflected, we do not see a dim spherical object traversing our sky. In fact, in the daytime, we should still see a dim object traversing the sky, but we have never seen either of these things in our realities. Can you ever remember seeing a dim, non-luminous moon high in the sky at the new moon phase? I repeat, at the new moon phase, not while it's waxing or waning, and not when it's near full. Have you ever seen a dim, non-luminous moon high in the sky at the new moon phase? Now that this information is being brought to light, you will never be able to help but notice something you've never noticed before. That on an eclipse, the shadow has never stretched along the surface of a spherical moon. No stretching, no skewing, no sharpening in or fading away. Not obscured and distorted in sine wave-like motions. No light reflecting onto the moon from Earth. Nothing. Not a single shred of evidence remains that the moon is a spherical body orbiting around or above our Earth. This 100% discounts and debunks any further argument or perspectives that hold to our moon being a sphere in the sky or reflecting the sun's light. This information is in line with the laws of the reflector. The reflector can only reflect light brilliantly if the surface of the reflector is concave, but the outside of the sphere is convex, and convex surfaces only reflect a portion of the light back to the viewer's eye. But a concave surface reaccumulates the spreading light, or reconcentrates the light back to the observer's eye, whereas the convex surface, like the surface of a ball, further scatters the light. If the moon were over 250,000 miles away, then we would only see a portion of the moon, which we would call the hot spot, or the bright spot, or the highlight of the sphere. But there are no hot spots or highlights or bright points on the sphere of the moon indicating the sun's direction. Instead, we have a perfectly evenly lit, luminescent moon that gives us cold blue light. In fact, when we look at a full moon, it appears to be flat because the edges of the moon are just as bright as the center or any other part on a full moon. Now that your eyes are opened to the physics and the facts, what will you do? Will you choose to continue believing this lie or observe it for yourself? Anybody can do it. Just go outside and look up. And in case you're wondering about what Neil deGrasse Tyson has to say on the matter, just look how he debunked himself. He went on social media, yes, supposedly the world's leading astrophysicist, anyway, went on social media and posted this ridiculous photo of what he thinks the shadow of a flat Earth would look like on the moon. Now, of course, he believes that the moon is a sphere, or at least that's what he says. But if that's the case, then why is there no stretching or skewing of this shadow? Once again, it goes to show you how important it is to be observant and to rely on your own senses. It also displays the innate sense for acute observation
It upsets all our ideas.
Folks, every photograph you see on a magazine cover is touched up and not the real image. That's just how things are. And I'm not saying anything's nefarious about doing that, but when you're doing research and you're trying to find out if something was in the sun or not, if the moon was there or not, and that data can't be faked. That's doing research. So I don't need the images photoshopped for me or the moon added in. The image that I told you that was real is this image here. And we'll just go to image adjustments. I'll do the same thing I did in the long video. And then we'll just maybe do some levels on this. But this image here is 100% real. There's no moon image in here. If you notice this blue area, there's no distortion in this blue area. That's because there's no image overlaid in here. Everything's even. It's not pixelated out, and there's just nothing in this image. When you shut off the different channel colors, the image remains the same. Nothing changes. All the pixel data is there on all 3 channel colors: the red, the green, and the blue. And so that tells me that this image is not manipulated, at least in the sense that a moon picture wasn't added on here. Everything in the image gradients out like it should. There's no extra image in here, nothing that would tell me that it's fake or blocking anything. And all the pixel data is the same in the whole image. And that's another thing I didn't cover in the other video. In the faked images, the pixel data is at a lower resolution than the rest of the image. But if we were to zoom in here, we get this real fine pixel data. It's nice and fine. You can see this. Now remember this, and we'll come back to this here in a second. This image here is the one soundly used on Globebusters. Now if we just go to image, and see what we can find here. There we go. Now we are getting a picture of the moon. So awesome. But in this image, we are also getting something else. And you can see this line across there. There is in a box pasted. I'll bring it on to something else. Now, the thing that bothered me with this image here, and if we zoom in, you can see how crazy how bad the pixel data is. Let me show you the real image here. This pixel data as opposed to this larger, chunkier pixel data. Smooth pixel data, chunky pixel data. Smooth pixel data, chunky pixel data. And so the chunky pixel data is simply because somebody's overlaid a lower resolution image in here, mainly a moon photo. And the other thing about this, unlike the other one, when we turn off the green and the blue, we still have our moon photo in here. But when I shut off this green channel, our moon photo disappears. And then once again, you can see the square box start to appear in here. And so this tells me 100% this image is fake, manipulated, and you know, this moon image should be on all these channels, which I showed in my other video. Unlike this image here, this is original, and once again, it stays the same. Nothing changes, no matter what color channel you're on, and that's the way it should be. So I found this box, and I highlighted it in here. Here we can see there's a box in here, and this box is in here because Soundly or Sean or somebody overlaid a picture of the moon on top of this image. It's there. You can't hide it. It's not at all in this image here. This image here is fine. It pixelates and equalizes evenly. This image here, not so much. It's right in here. We get that box image that somebody overlaid, and that was the moon. Here's the image. I brought it out a little more using this, but if we, it's just on the green channel. It's if we enable another channel, look at it, it's not there. On the red channel, it's not there, but we enable the green, it shows up. Disable the green, it's not there. Blue channel, same thing. If we just use the blue channel, it's not there. You just get this pixelated mess in there because they overlaid something on top of there.
So just to talk Eclipse here. I know Mark is saying you have a hangout later on with Mike Helmick and a few others, so I'm not going to get too much into the image processing. I'll leave that with you guys for later on. But this, what I'm going to present, will definitely back up what I'm sure Mike and your group will be talking about later with the Photoshop and the imaging, trying to bring out a moon in the image is the main key that we've been trying to work on. So what I did was I went and made a model of an eclipse. This is a 3D screenshot. So this is in Blender, I made a model, put a solid object in the model, put the light source behind it, put in the atmospheric particulate matter to the right ratios and densities of air, and with the right anisotropic properties of light coming through an air medium, and hit it with the light to simulate the sun, which is this is to scale, so it's at 1.5 million lumens, and the distances are correct to try and simulate an eclipse. And what the model renders, as you can see, you would expect to see a crescent around the actual object itself as it enters into totality, which no one saw or observed in reality. And then I went to the next phase to say, okay, well, how would the light distribution work within that type of anisotropic particle system? So as light hits a solid object, you would expect to see the same crescent with a little bit of backscatter lighting around it. As the light comes around a solid object, you would get a rendering of the entire orb, i.e., if it is the moon or a solid object, in the field in the camera lens with the filter on, right? And you should see a bouncing effect off of the front face, the leading edge. As the light hits the object, it bounces out radially, right? So that's what all these lines are in the blue spectrum, because it goes to red and then slows down as it reflects it, it polarizes. So all reflecting light polarizes and heads backwards and creates this effect on the other side. And then the non-polarized light comes around the other side and creates these halos, which is what we see normally, moon halos, sun halos, rainbows, etc. So that's actually what light is supposed to do. And then for a comparison, so this is my control, right? This is what it should look like. And for comparison, I took some moon shots from some friends of mine, really excellent photos. Did the same process on it, didn't change the settings. I just changed the process, just changed the photo, used the same settings for the analysis. And a moon shot would transpose to this. So you'll see this is the crescent at the front, now brought forward, and you can still see that there is a moon object in the background. This is like backscatter light. And then I compared that to, let's see, this image here. This is during the eclipse as it approached totality. And what I found the most fascinating about this is you get the red split spectrum that appears in the sensors of the cameras, which isn't that unusual. You see refraction and lens flaring that kind of splits the image in the red spectrum. But what was fascinating was this thing here, being that it's an inverse image of this side of the object coming around and being inverted backwards and being forward projected. So it's being forward projected to you as the observer on the ground to a centralized focal point. So it's this thing, whatever it is, whatever the light's coming through, being refracted and being projected like a lens to you at the ground and appearing in front of you. And you can kind of see, if I zoom in a little bit on this image. Oops, go back one, right there. So this is the actual object being refracted, and there's a whole bunch of little tiny ghost ones in the air. Right, you can kind of see them being split out in the air. And what happened during the eclipse, well, I'll show you how that analyzes actually first. So what I analyzed was I took it to the spectrum gradient to take out some of the red and bring the black forward, right? So I could, wash out all the interfering light patterns to see what I could see. And it renders out to this here. And there's some interesting things in this picture. So here's that object again being forward projected. There is something, a little bit of a dot up here that appears to be a physical object of some kind. And then this gradient shows the edge of whatever is causing the eclipse. It cannot be seen, so it's actually not visible. Because when I take it to the other spectrum, like I did with the moon and my control, there's nothing there, right? Absolutely nothing. Except you can see that something is causing the magnetic field, which is, light traveling through the field is photons, and photons have magnetic fields. So, magnets can bend light as they travel through. They become polarized. You can see that this is the focus point, and those little half moons do kind of sort of appear in the gradient. But whatever's causing the eclipse is completely absent. There's nothing there. And so what I went to the next phase of the analysis to see, well, what can I see if I invert that to a negative and amplify it? So I did that to try and find out what was there, if anything. And then what I found was, well, there's the light because it's intense, so it comes out just as a gray wash because this is a negative. And whatever is supposed to be there is not there, but you can see that it is having an effect on the light scatter in the negative field. And whatever is coming through that object down to create this half moon is causing a bending of the light being forward projected down here. So the angle's coming through from the top right down through the object, appearing here to be forward projected to the center of frame, and then scattering in the background below it in the left. So that tells me there's an electromagnetic cause. There's an electromagnetic force that is causing this to happen in that gradient. And I did it in 2 different gradients just to amplify it to see what's really happening here.
Well, that's pretty amazing.
Yeah, it is. Yeah. So then the next thing is, okay, well, what's causing that, right? And the typical NASA response in their videos online and the mainstream media is that what we're seeing, that blue object, if I go back here, this blue object here is coming down through the atmosphere plane above our heads, through our air and everything else. And it's being forward projected and causing all these little moons on the ground. By the millions. People took thousands of pictures of these. Sometimes, depending on if you were north of the equator or south of the equator, they would appear upside down. Or if you were north of the equator, they appeared the other way, right? With the crescent facing up, and they were being inverted as a shadow. So this is like the same image being rendered as white light on the ground because it's going through the blue into the white and spectrum change. So then I said, well, where's that actually happening and what's causing it? And I looked at some high altitude footage at 75,000 feet with the 360 camera. And that's what the eclipse looked like at 75,000 feet through a 360 camera.
Wow.
And there's all those little orbs again. I was like, wow, right? Like literally, wow. And there's the orbs. And you can see that, there could be a little bit of frosting or ice or whatever on the lens camera, but it's at altitude, right? So it's cold up there, 75,000 feet. But that doesn't say that that's the cause. What that tells me is the angle of light that's being projected to the lens, because you're getting an unequal distribution of light scatter. Some are over here. This one's being illuminated more than this one. This one's a full dead-on center. So this means the light's coming almost perfectly to the center of the lens as it looks out through the medium. You're getting a really nice rendering of the image. So that tells me that's a multiple diffraction pattern, right? It's coming from all angles in a like your perspective, right? Your degrees of your perspective coming at all angles into a center point. So it's multiple diffraction, right? There's no way of getting around that. So this, millions of these diffraction angles are now being projected down onto the cat. And it's not just cats, it's dogs too. There's a dog. Right, so we're going to be fair. The dogs got it too, yeah. It's raining cats and dogs. Yeah. So
raining moons on cats.
Raining moons on cats and dogs, yeah, exactly. So, you know, we've all kind of most of us have seen that video where, you know, it was particularly NASA was trying to explain that, oh, that's just a pinhole effect where the light comes through the trees and causes the trees to act like pinhole cameras, and you get multiple projections on the ground. Well, being an artist and painter, I mean, that's another one of my hobbies. I do music, art, and paint. I know how pinhole cameras work, right? And what a pinhole camera will do is you can take a pinhole camera light, and what it does, it'll actually invert the image, but it projects the entire field of view, right, through a pinhole, and replicates the entire image on a background, right? It is true that pinhole cameras will work, but pinhole cameras will not split multiple images into multiple refractions unless it's coming from multiple angles. You see what I mean? You'd have to have a million holes in this type of screen, or on that mirror. This one's actually being projected through a pinhole and reflected off and bouncing in the room. But you'd have to have millions of holes in it, and each image coming from a different angle in order to get multiple images of the same thing from all different angles, like a three-dimensional effect. And that's what that is on the ground, is a three-dimensional scattering. Right? It's coming from all angles, every direction, multiple intensities. So there's no way to say that that is a pinhole camera effect. And we have to reverse that in our minds. So here I'll show you something here with the moon here. To be fair, we'll compare a picture of this image I showed you before with that orb thing, compared to a moon that Judith sent me. This is one of Judith's pictures. And she had sent me, and she said, here's the red. So the red is normal, right? And this green here, greenish area, if I was to invert that and do the same thing, you would see that, well, that's this just being reversed, right? That's normal. Light bouncing, there's the orb. But in this case, there is nothing here, and it's being forward projected through a lens, right? That's the only way. That's the comparison. The moon will scatter it and cause a flash image or a flare of itself. And this is completely different. So it's not the same thing. So then I concluded that, let me see what else is going on. One of the best explanations I could come up with in a model to say how is that happening is this image here. So I took it into a model. I made an orb. This is a plasma field of UV light. This is a solid object in a 3D model. So the light scatters everywhere within the model itself. So it's just like a square, but the light source scatters everywhere. So it's going in all directions. But since the source is localized to a projected point, as the light bounces around in the field, the particles go through the orb and go back to the source. So that creates a shadow. So if you imagine that you were standing inside of this orb looking back towards the sun, you would actually be seeing your own shadow, canceling out the light that's trying to reach you, because now it's going back just as fast as it is trying to come towards you. It's your own shadow, in essence, traveling backwards. That's one of the processes I'm trying to understand, see how that works. Then I simulated in a model the same setup. So I took a light, a very intense light, 1 million lumens. This is a solid, right here is a solid moon simulated object, or something to interfere. It's a sphere to interfere with the light. And then this area here is a simulated dome lens to give it something to appear on and focus on. And then this field underneath here is a particle field. So it's a semi-transparent particle field to simulate the atmosphere. So it hits that, bounces through, creates the half moon through the air, and bounces on the ground to create the half moon over here. So that was my first attempt to say what can be causing this. So you can see that in this rendering, in this model setup, it's just a projection, like a standard projection at a movie theater type of idea. So it's backlit. This would be like, what was his name that did the one with the monkeys? You know, the Space 2001. Yeah, Stanley Kubrick came up with this back projection type of thing, right? So the whole NASA thing. But anyway, that's kind of like what they use. But you can see you only get one rendering of the image, and as it travels through the lens, hits the air, travels to the ground, it expands to create, you know, what would be a shadow on the ground or illuminated crescent. It's not making millions of them, right? It's only making one. And no matter where you move with the light source, you're only going to get one image projecting forward through that type of lens. So that tells me that in order to make this happen, you need millions of lenses, individual crystals, and the light has to be traveling down the center of a crystal to be projected like a hologram or like a laser. Like when you do a laser, you send the light through a crystal, make a perfect laser, focus the light, and then it hits the ground like a laser beam from many, many angles, all at the same time. Eclipse, without an object being there, the best explanation I can come up with for that so far is electromagnetic interference. So the light is there, but whatever that object is a black body radiation absorber that has an intense electromagnetic field, enough so that it'll allow some light to pass through its periphery surface because it must have a boundary layer to have a charge, but it's so negatively charged on the inside, it absorbs everything that comes into it and lets very little of it come out. What does come out comes out in the blue spectrum, and what is inside of it is absorbing all the light. It's just making a black hole. It's like literally a black magnetic hole. Nothing comes out of it. So I took that idea and I took this image of the eclipse sent to me by a friend and started to say, okay, the light scattering from around the outside is following a magnetic pattern. This is just a magnetic toroid. So I'm trying to visualize that in 3 dimensions to either rule out that it is an electromagnetic orb object or a planetary object that's above the dome and interfering with the light path trying to reach the surface and just canceling it all out. And it has some interesting ramifications too. What happens, you know, the NASA thing where it's a forward projected image on the ground makes absolutely no sense. Because if I showed you that picture of the moon here again, let's scroll up here. There's the moon, and we should see that if that's actually reality, and as light passes through trees, right, then every crescent moon and every moon phase would come through the trees at night, and you would see animals in the forest that look like this, right? They would adapt, right, to be camouflaged, right? You know, every bird that flew over the sky as the moonlight came down, or the sunlight came down, would be projected as a secondary image on the ground, and you'd have, you know, one bird would appear like an entire flock on the ground, and every animal predator be running around chasing ghosts that don't exist, right? So if your mind is going to accept that forward projection thing of NASA and pinhole cameras, I'm just suggesting you think again, right?
Can I ask you something, Chris? Is this only happening at the eclipse, or does those pictures with the shadows of the moon, or can that happen at any time, or is this just in the eclipse?
This is just during the eclipse. See, and that's what makes me ugly, is because I think it was either Time or Now This did the NASA video, and it actually says in that NASA video that this happens normally all the time. Sunlight or light, this is a normal process. Well, that's a complete and utter nonsense. It's not a normal process. It only happens during eclipses. Like I said, otherwise the moon would do it every day, right through the forest and the trees, and the sun would do that every day. If something passed between it and a pinhole camera in a tree, and there was a bird sitting in the tree, well, then you would see 1,000 birds on the ground, right? It doesn't happen, right? And it just blows my mind why that is. Yeah. But the long story short, if I can bring up some other,
Can I just say, in the chat room, Ditra, Dave, down the rabbit hole, Dave, he asked if you would show your tree. with the apples in it.
The tree, yeah. So clearly what's going on to me is that we are, you know, on the plane of inertia, right? We experience in this center point where the two negatives and positive come together and balance in a neutral. We experience a slightly biased system that's slightly biased towards the positive. So it keeps us down, right? We experience that as gravity. We're on the plane of inertia in the center of a magnetic field, toroidal, like a double toroidal field. All the light that's outside of it is coming through the firmament. You could call it the firmament, the dome, which could be, I don't know what it's constructed of. It's, you know, like molten, liquid molten glass that keeps everything from, you know, keeps us safe. It creates a dome so that we have pressure in the system. You can't have an open system to vacuum and still maintain pressure, right? It just doesn't work. So you have to have something to contain the pressure that we experience as atmospheric pressure of 14.6 psi, whatever the number is. It's around 14 psi, right? And that's the only way that would work. And we're on this inertial plane, and this is like the tree up the center cone, right? The tree of life, the whole 9 yards. It's right there, and it goes in both directions. There's a negative and a positive. We just happen to be on the positive side of it, right? Which gives us the sense of gravity, but it's also neutrally negative. Like our bones are made of dielectrics, calcium, you know, our bodies are made of water. We have salt in our bodies. We have some iron in our bodies. So if the iron flows in the positive direction, it allows our blood to flow. The dielectrics and the negative side of it in our bones is actually what's holding us up. So it's the bottom side, the negative, that's actually allowing us to stand, because it's actually levitating us to a certain degree, you know, helping our bones, which are calcium, float in a magnetic field. So that's the basic construct, and we're in the center of it. So then I got looking at the electrical side of it and studying the moon. Since we're talking the moon and the eclipses here, a friend of mine, Brad Gillen, he sent me these pictures, and what we did was oversaturated them just to bring out some of the colors of the image we were seeing. And the images in the color phase lines up with anodizing of titanium and other rare alloys. So the charge that causes the craters, which are all at 90 degrees to the surface, so nothing comes in at an angle, they're all sparked and arced to the surface to cause the craters on the moon. You can actually see the approximate voltage required at each point if you do it in a color spectrum, right? So as color changes, the more you saturate it, the deeper the color. So the golds are at about 50 volts, you know, million amps, whatever it was, right? High amperage, right? Low volt, high amperage, and just went bang and creates this crater, right? Some of them are negative, some of them are positive. The ones that have a raised center would be, you know, the inverse of the ones that don't, right? It's just an inverse polarity. And you can call out some of the, you know, people that are trying to post images like this one here and superimpose the moon over front. I'm sure Dave or Mike will probably talk about that when he meets up there, but so I won't get into that too much, but that's what it really looks like in reality. So let's see. The next thing is kind of some evidence of that is, in order to have a multiple diffraction, right, of it coming through a lens and getting more than one image on the ground, you have to have the object between, and the lens is between, the object is actually between the light source and the lens, and it just diffracts into multiple images. And here's another image. Now this person got a cool image. This came, Monique Chenard from Moncton here. She sent me a video, a link to a fellow that actually was talking about the Moon Group and asked me to get another video and to take a look at this. So I grabbed a screenshot just to discuss with everybody. My initial thoughts on this was that this is an image of the eclipse in progress. And you can see that this is the sun and this is the occulting object. It's being refracted in the red spectrum. There's a bit of duplication of this image in the center of this green orb here. So there's a duplication of it in red. You can kind of see it's very, very faint if I zoom in there. Sorry for the phone ringing there in the background. So there it is again. It's kind of like purpley pink here now. So that's just this image duplicated. And because of that, you can deduce. You say, okay, well, if this image is being duplicated slightly as a doubling effect, so that's a double image, then this green image is a double image of this red image. And if I was to take that out and do some color spectrum, if I had the original image, you could probably do that. And you would say that this Ankh type shape with the polarized plasma bouncing around inside whatever that is, it's like a plasma ball, you know, the ones you put your hands on, right? Static charge, the plasma's on the inside, you touch it on the outside, and these lightning bolts, you know, dance around the glass, right? That's, to me, that's my first instinct, is that's exactly what that looks like, right? So I'm leaning towards some sort of a, outside of the dome, there's another object that the light's passing through, canceling out the sun and projecting it forward. And it looks to be spherical of some kind, or some kind of a lens. And yeah, it's like the Ankh, that's the Egyptian Ankh type of shape. That just kind of blew my mind when I saw that. So I'm looking into that one with some more detail. But the main rub here is that the system and the plane that we're on in this reality, like looking at all of this evidence and the eclipses and everything else, is that the whole secret of the system is a dielectric neutral on the bottom, which goes back to that, the tree shape there, the double toroid. So we have the negative and the positive on the bottom, and the circuit, like we've gone through all those circuits of the ancient history with the cities being destroyed and the craters in the ground and all the destruction in the history and everything, is basically this. It's the earth and the oceans are a dielectric, and of course it has positive and negative, you know, iron mountains versus, you know, salt mountains and everything else. It's obviously well distributed, but it has a bias to the negative dielectric. And then the positive is on the outside in a Gaussian sphere, like under the dome. The dome would have its own charge, capacitance. Essentially, it's a giant capacitor. The dome itself is the outside boundary. And then the Earth center is a neutral. And it's just a positive and negative dielectric dance in the middle. And if you had an air gap, right, to the ground and the air, and then plug that into the water, you've got the circuit that Tesla had in Tesla's tower. Right, it's exactly the same circuit with a coil on the top, a pipe into the ground, tapping into the water, and the ground circuit, and then an air gap in the vacuum in between, and the coil takes it off as a charge. And that's exactly what Tesla was doing, and I think that's why J.P. Morgan and all the rest squashed and confiscated and hid all of his work, amongst others. I mean, every time someone tries to come to the surface and bring this forward, it just gets squashed, because I think, one, you have to treat it with a lot of respect, because if you don't do it right, you know, you could be bringing down whatever it is above our heads onto our heads if you don't control it properly. And two, it's a free energy circuit. I mean, it's an unfathomably huge, never-ending free energy source, right? It's easily tapped into. It's just three-phase power with a vacuum gap. But, you know, you'd have to regulate and treat it with respect, obviously, and you don't want any Joe Blow out there trying to tap into the sky, because it's a dangerous source. And that's the thing, that, you know, they don't want that information coming out, whoever they are, you know, the ones, the powers that be, that want to control the energy and the oil and the power and everything else. It is really that simple. It's that simple a circuit. Just to go back to the eclipse thing, I did a little bit of an analysis here on some eclipse photos. What I did with this one is pretty much the same phase that I showed you before, where it's, you know, partial eclipse, and the object you can't see it, but the object would be in this zone here, and I'm zooming into just the edge of the object, right at the edge of wherever that arch is. And when I zoomed in on it, right, you can see that, yeah, it looks like there's craters there. Right, there's some craters and, you know, some backscatter light inside the black spot, right just at the edge. And I zoomed in on that and tried to get some images of it to see what it was. Different ideas. So that was interesting in itself. But then what I also did was I checked the other side of it. Right, you have to check the other. If you're going to be looking at it, you got to check both where the image is being occulted and what's being scattered on this side. So this would be, in theory, on the other side of the sun, and you get the same images appearing in this field as you do over in this field. So it's the same thing on both sides, whether it's on the black side or the red side or the lit side. It's the same type of effect. So it's just backscatter, photon radiation that you're catching in the lens. So it doesn't indicate that there's any moon there at all or any object, because you get the same thing either way. It doesn't matter. There's no evidence that that is actually the moon. So it's found it quite fascinating.
So basically, nobody saw the moon before, during, or after the eclipse.
That's correct, in my opinion. Yeah.
So the conclusion would be that the moon didn't cause the eclipse. That would be the logical conclusion, right?
That's my logical conclusion. Yeah, it wasn't observed. Now, it's not to say that the moon during its phase of new moon isn't in the proximity of the sun and or behind it or somewhere else in the same field, right? And both are being occulted, right? Because we know the new moon phase is being occulted during the new moon. It just, once a month it does it. That's a natural thing. So the difference is that the moon would pass through that cancellation field, every month, but the sun only does it, 3-4 times a year, right? So the constant is that there is something that is interfering with the light of both objects, right? A new moon is essentially a solar eclipse. It happens once a month. Right. The phases of the moon is a perpetual eclipse. It just phases in and out of eclipse phase, right? It just never stops. But the sun only hits that point, 4 times a year. It's just a different path of the light. Right.
So could the sun be acting like the moon's phases, just only several times a year?
Yep, that's what I'm thinking. Yep, exactly the same thing. So whatever's causing that it's consistent with both, but it's independent, right?
Yeah, makes sense. I mean,
yeah.
With those photographs we all saw now, it kind of makes sense.
Yeah.
And what about I was thinking about the meteor craters, which are obviously not caused by any rocks from outer space. So
yeah.
Could it have something to do with this electromagnetic force and with their lunar craters that we see?
You mean is there a tie-in between the craters on the moon and the craters on Earth? Is that what you mean?
Yes. Could they be caused from a electromagnetic force acting under the Earth somehow?
Oh yeah, absolutely. Yes, that's exactly what it is. In my opinion, it's the majority of the craters on Earth are caused by electromagnetic strikes and the cataclysmic type of arcing out. And it's quite possible that at one point in history, ancient history, the moon was actually involved in a huge electromagnetic storm, shorting out to the Earth's surface. Absolutely. That's people want to kind of look into that theory and stuff and how that actually works. I recommend the Electric Universe websites, and there's 20 years worth of research there. But the interesting part is you can't find that on Wikipedia. It's actually a banned topic on Wikipedia. So the mainstream is not allowing anyone, or they're trying to stop people from looking at the Electric Universe theory because it backs all this up 100%. And even though the Electric Universe, I think the majority of those people that are studying, because they're all PhD electric, physicists and plasma physicists, and it's really high-end stuff. But the majority of those people aren't flat earthers. But the foundational principles upon which the Electric Universe theory is built is exactly this principle, right? It's a dielectric field. We're in a dielectric circuit, and we're in a capacitance type of process between the two. There's a charge differential. As above, so below, but it's inverted, and it's just backward.
When you see, for example, this situation, you must be assumed, because when you see in real time, and you can see this is from 263 kilometers, you see the sun, you know, assume we are on the ball Earth, you see the sun setting down. So in what time this situation becomes? Because when you see this, you see the sun come from up to down. So right. At what moment this, you know, transition happen? When you start to see the mirage, when it start happen the mirage, when supposedly right now the sun is down, but 2 seconds early the sun was up. You know, because if we assume this situation, we must believe that the sun start to invert his position. You know, like right here, you know, at the beginning of all this video, because there is a lot of examples of this. So just, I mean, right now the sun must be at this position here. And there is some videos that shows the sun come, you know, from early going down. So at what time this transition happened, that is the first thing that I start to think. But this picture is taken from 320 kilometers away at the altitude of 300 meters. So, sorry, it's taken at 320 meters with a distance of 263 kilometers. So if you go straight in geometrical situations, this part of the mountain never must be appear, because it's like 400 meters below the horizon, because the Canigou have 2,700 meters, and based on the calculations with the standard refraction, you will lose 400 meters of that mountain. So supposedly we must believe that this object was raised up at the horizon level and the horizon line, which is something never happens, and with a perfect silhouette definition, which is something never happened, 400 meters.
Yeah, impossible.
It's impossible. And when
without flipping upside down too, right? Because
exactly.
We know that in Fata Morgana, the image actually inverts, right, 180 degrees.
Exactly. And when you
should see the moon actually, you know, half the moon flipped upside down and flip flopping, and
yeah,
at least thinking out loud here, just thinking off the top of my head.
In fact, when you see the Canigou effects, it's something that is really you can clearly see how the image of the sun begins to going down. You can see the deformation. So at this particular situation, all the indications from the atmosphere is that the image was going down, not going up, because you can clearly see how the distortion of the supposedly everyone knows that the sun is a perfect disk. So here you can see how the lights start to, you know, deforming and pulling down.